Welcome to Chapter 2 of the summer assignment for AP Chemistry, and wanted to just take a quick look at this with you and see if there was a few things I could point out that you want to be sure and think about as you're studying in Chapter 2. Of course, there are interesting questions like this, which is true about an individual atom, and I think we're going to just save that and see what you think about when you get to class. Yep. What did you think of this question? Now, for many of the rest of the questions here, you'll want to be sure and refer to this kind of a systematic way of thinking of nomenclature. And this particular flowchart is one of several flowcharts in your textbook that you may find helpful if you're struggling with naming compounds. So in this particular flowchart, we're looking here at binary compounds, compounds with just two elements, like this one. Here we have calcium and the chloride ion. And is there a metal present? Well, in this particular case, yes, the metal is calcium. Does the metal form more than one ion? Well, no, calcium only forms one ion. And so the authors of your textbook call this a type 1 binary compound, and they use the difference between type 1 and type 2 is whether or not you use the Roman numeral. So this would just be calcium chloride. Now that would be the official name for this compound. And I guess why is calcium dichloride not correct? Remember here we're looking at a systematic naming method where we all have to follow the same rules. And so these are the rules used by the International Union of Pure and Applied Chemists. And this is the system that's been developed. So I think you will find if you're struggling with these, go to the flowchart, say binary compound. Well, all of these are binary compounds. They only have two elements. Is there a metal present? Well, in this particular case, there is no metal present. And so this is when we use the prefixes. So this would be dinitrogen monoxide. Here, we see a metal is present. So get rid of the notes here. Come on, erase. Having trouble erasing the marks. I'm going to go back through here. There is a metal present. So yes, in this case. And does the metal form more than one cation? Well, yes, it's copper. Remember, many of the transition elements form more than one cation. So it is a type 2, so we have to determine the charge of the cation and use a Roman numeral after the element name for the cation. So this would be copper, and it must be a charge of +2 because you've memorized that oxide is, oops. Oh, we better try that again. I'm really going to wish I had an eraser working. There we go. Oxide, you've memorized, is -2, so this actually has to be copper +1, doesn't it? You thought I'd messed up on that. Just about did. So this would be copper Roman numeral 1 oxide. Time for me to wake up here. Okay. So you should be able to finish number 24. Number 27 looks at this question. If you have these three compounds, hydrazine, ammonia, and hydrogen azide, if you take 1 gram of nitrogen that's found in each, if you take these compounds and you combine 1 gram of nitrogen, how many grams of hydrogen would you find in that compound? And so the question is, how does this data represent the law of multiple proportions? I would ask you to be sure as you come to these kind of problems to go to your textbook and see, is there an example in your textbook? And there actually is. It's sample exercise 2.1. And so if you look at that sample exercise 2.1, and it's on page 42, they will explain how this works. All the masses of hydrogen in the three compounds can be expressed as simple whole number ratios. In other words, let's look for which one of these numbers is the smallest as far as the amount of hydrogen. Here we have, which one of these is the smallest? Well, it's right here. And if you divide each of these by the smallest, well, this divided by itself is going to be 1. And this divided by the smallest, 2.4 times 10 to the negative 2, is going to be 9. And this divided by 2.4 times 10 to the negative 2 is going to be 6. So that's where we get this 6 to 9 to 1 ratio. And read more about that there on page 42. Number 32, what would be the diameter of the hydrogen atom in a scale model if the nucleus was 1 millimeter? Set up a ratio and proportion like this. So the thing you're going to have to do is decide what these two numbers are. What is the size of an atom? What is the size of a nucleus? Do some research. You're going to find various numbers, and so your answer may be within a range. So I encourage you to go work on that by doing some research on the internet. Name these elements. Well, you should be able to do this without looking them up. In other words, you should know that this is tin and platinum and mercury and so on. You should know that without looking them up. And also, as you think about these elements, you should think, what are the properties of metals? They conduct electricity. Where are they on the periodic table? How many valence electrons do they have? All of these things contribute to the fact that these are metals. Name these elements, and once again, you shouldn't have any difficulty with this. Should be able to do it without looking them up. And you'd also want to consider, where are these on the periodic table? What are their properties? How many valence electrons do they have? Even questions like, what do they look like? These are things you're going to want to start collecting in your mind. In other words, helium, you know what that looks like. It's a colorless gas at room temperature. The density of helium is lower than air, so helium, you know these things. Don't forget to start cataloging properties of these compounds as you encounter them either in class or outside reading. Carbon, you probably know, comes in several forms: charcoal, diamond, and graphite. So think of those things as you're working through this chapter. You should be able to also identify these as metals or nonmetals without looking at the periodic table. So, remember that if we have periodic table here like this, that there's a line. Didn't get it quite in the right place, but there's a line that separates metals and nonmetals. And remember that as you move across from metals toward nonmetals, the properties of these elements become less and less metallic. So there are some things that are right here on this zigzag line that have a lot of properties of both metals and nonmetals. And those would be things especially like silicon. And because of their position on the periodic table and their properties, they have particularly useful properties to us. So